All right, good morning, everyone. They did not tell me that the walkway by Parliament was closed, so I had to go all the way around, so that's why I'm just a little late getting here. No worries, though. My name is Jimmy Bogard. You can find me on Twitter at @jbogard. You can find this code, the presentation and all the slides on my GitHub at github.com/jbogard. There's a presentations repository there. I blog about this and a lot of other topics on my blog at jimmybogard.com. So yes, before we get too far into domain-driven refactoring, I want to talk a little bit about what domain-driven design is, just to kind of do a little bit of a level set. Actually, let's see if I can. One second. Now, and trying to extend. There we go, so I can actually read my notes. And oh, okay, yes, there we go. So from the domain-driven design book, although it's, that domain-driven design book has a lot of great definitions of things, it doesn't actually provide a great definition of domain-driven design. So this is one where I kind of had to glom things together from a couple sources just to try to get it in one single sentence. But domain-driven design, in one sentence, is an architectural design strategy in which we selectively distill, organize, and abstract the body of knowledge from the users to the software. And there's kind of three key words there. One is to selectively distill. So we're not trying to take everything that's possible in the real world, or everything that's possible that the users are doing, or everything that's possible in the business, and try to put that in software, because that's impossible. We'd never finish writing software. So we're trying to pick and choose what are the most important things to be able to represent in our software. The second one is to organize. So trying to avoid the big ball of mud mess. And trying to organize it in such a way that also makes sense to the business as well. Maybe not from a complete software perspective, but at least that they the things how things relate to each other, the different kind of components that those have somewhat analogs in the real world as well. And the final one is to abstract. And the reason why we need to abstract is the real world can be really, really complicated. And so you probably know when you talk to your business or users and they start talking about how they do their business and how they accomplish certain tasks, and they'll just start rambling on and on and on and going on and on forever. And well, we can't do all of that. So we need to kind of take a step back and say, well, what are the kind of main themes that do we have here? And that's that third part is abstraction. And so the three things here we're trying to distill, organize, and abstract is really what domain-driven design is all about. And one of the big key components of domain-driven design is this domain model that represents the kind of object model of the business. So even the idea of a domain model actually predates domain-driven design. In the Martin Fowler book, Patterns of Enterprise Application Architecture, he describes a domain model as an object model of the domain that incorporates both behavior and data. And so there's two key components there. There's the data part, which I think all of us kind of get more or less right. The second part is a more complicated part, the behavior part. Because most systems I see that try to get the names right and try to get the data right, they don't have the behavior part of it. And so but that's okay. This talk is all about what do those systems look like that we don't have the behavior in the right parts, we don't have the behavior in the domain model itself. Instead, the behavior is kind of scattered all around the system. And so that's what most of my systems I see wind up is okay, yes, maybe the names aren't even right, but the behavior is there, it's just kind of all scattered about. But that's okay. We can follow the normal test-driven design steps of red, green, refactor, or most legacy code that I see is just what tests, and then just refactor. Now this is where, in terms of techniques and how to accomplish this, These are none of the things I'm going to be showing today are things that I made up myself, although I guess I could take credit for them. Someone would call me out on Twitter, and then it'd be a whole thing. These are all things that have been, and all techniques that have been well documented over the years. And there's 3 main books that I work from to pull together techniques to build out my domain models. The main one I work with is Working Effectively with Legacy Code, which really is just like, how do you refactor code without tests, which is a lot of legacy code that I see these days. And by the way, he defines legacy code as just code without tests, because it's hard to change. The other 2 great books, of course, are Martin Fowler's Refactoring book over there on the left. The second edition is JavaScript, so whatever. And then one that's actually out of print, unfortunately, but it's my favorite design patterns book, is Joshua Koreski's book on refactoring to patterns. And all of these books take the concept of, instead of like Gang of 4 having like, here's just the list of patterns, and you just kind of pick and choose whatever you want to go from, or like more of these prescriptive styles that said, if you just get your code in this structure and this organization, then everything's going to be fantastic. But I found that in like real-world applications, there's no structure or organizational style or set of patterns you can blindly apply to have good code at the end. Instead, we have to get good at these techniques described in these books to build out good domain models. So I'm going to be working with a current system, a current application that more or less represented one that I was working with years ago. So just want to walk through the current state of this application, this sample code that we have right now. So this sample code is dealing with a loyalty reward system. And in a loyalty reward system, we have a few major components. And some of you are probably, actually probably all of you are part of one of these things. Like you go to Boots and they're like, are you part of our preferred club member or whatever? In exchange for your personal information and like all your spending habits and all your data, they'll give you like a discount every other month or so. So there's a little bit of an exchange there of like, give up a little bit of privacy, and here's some discounts or whatever. And that's what this system was represented. So this is just a class diagram of our current, quote, domain model. Over on the left here, we have our member object. And so right away, we can see like we're not trying to represent everyone in the world. So we don't have like a person object here or a human object. Instead, there's that distillation where we have a member object that is representative of a member in this system, not just any person walking down the street, because not every person in the world is a member of this system. Only people that have like opted in and said, I will give you my personal information, are part of this system. We also have offers. Now, offers are those like discounts given to individual members. And so as part of this, each offer can have some kind of type. And this is kind of like the metadata associated with an individual offers. So offer types are things that someone's going into some kind of back-end management application and configuring and saying, we're going to have this offer at this time, and oh, it's Jubilee, so we're going to do a Jubilee offer or whatever. So those are all configured in the offer types. And then when I go to actually assign an offer to a member, that's when these offers pops into play. So from this, we can also infer that the offer is associated with an individual member. And we can see that by those different associations there, that a member has a collection of assigned offers, and an offer can only be assigned to one member. And so the idea there is that if I assign a single offer to a single member, then no one else can then use that offer. So I could show this to the business, and even though they don't kind of understand like what does class mean necessarily, and what do these weird carets mean, and what is that little, I don't even know what that little gear means, but whatever. That they can look at the names of these things and the relationships, and it would make sense to them. Like, oh yes, we have offers assigned to a member. We have member information there. Everything looks great, right? Even the names of the associations match the names of the relationships in the real world. It's not just member has offers. Well, what is the nature of that relationship? They're assigned offers. So they could look at this and say, yeah, that looks all correct. And by the way, if it doesn't look correct in your domain model, that's still possible to like refactor towards. I won't go into that in this talk, but it's still perfectly possible to take names that don't match and then make them match through a series of steps. So they could look at this and say, yep, everything looks great, so ship it. But there's one problem here. You'll notice that my quote domain model only has properties. There's no methods. There are methods, but I hid them from the picture. There's like equals and get hash code, and those aren't really like domain behaviors, but they are technically methods, but I hid them because it'd be confusing here. But there's no actual like domain behavior on these objects whatsoever. But that's not the whole truth. Like, behavior does exist in this system, but where's the behavior? Well, it could be in, let's see, member controller.post. It could be in button click.save or button save.click or button save underscore click if you're gosh in Web4's land. It could be in like React code. It could be in like member manager, member helper, member insert generic object here. So that behavior definitely exists in the system. My system is not doing nothing. It's not just like showing data on the screen and that's it. There's going to be some behavior associated with the system. But it's just not in the domain model. Instead, it's scattered about the application. So I have to go find where the behavior is. In this case, I've got like a services folder, and that's where I'll like just dumping ground of all the logic of my application. And that's where I'll actually find the real behavior. All right, so now let's switch over to the code, and we'll walk through refactoring of some of these services. Okay, so over here on the right, I've got my model that we showed earlier, so the names all match, blah, blah, blah. And then the services folder, that's where like the real behavior of my application is. And if you want to get technical, like the design pattern being used for my current services is known as a transaction script. And let's look at one of these different actions to see what's going on here. And what I'll look at first is, this one says assign offer handler. So that sounds like it's the handling the logic of assigning an offer probably to a member. Nope. There we go. All right, I'll go ahead and hide that. All right, so the first thing I like to do in one of these kind of like I'm looking at a class for the first time is to look at the using statements to understand what are the things that this class is working with. And so you see kind of the normal ones like using system. Well, it's hard to get away from that. Then we see using system net HTTP. So that's telling me that it's using web services or some kind of HTTP directly here, right? It's like using HTTP client probably directly inside of here. Not probably, I know it is. Now it's using system text JSON. Okay, so it's calling a web service and probably having to deserialize some junk as well. Threading tasks, like can't get away from that anymore. That's all over the place. It's also using the model, and it's also using mediator, but that's like immaterial for all of this. The next thing I like to do is then look at the constructor, and hopefully it's using dependency injection so I can see what are the different classes that this object uses in order to perform its work. And I saw the one piece which was HTTP client, so yes, that confirmed our suspicions that it's calling out to a web service. And the other thing, of course, it's going to be using is entity framework. So it's got this app.db context, and that's where that before model namespace came from, is it's giving us that DB context there. So it's calling web services, and it's doing data access. That's like 95% of the actions in the system probably. It's doing data access and maybe calling out to a web service. All right, so this class has one single method called handle. And you can kind of imagine that this class is like, this is the main action that executes when someone like clicks a button on a screen or whatever. So I've tried to remove it a little bit from like controller-y stuff or front-end-y stuff and just like kind of the meat of the actual request work being done here. So it takes an input of a request object. So this represents like all the input parameters to do this work. And that request object has just two properties, the member ID and the offer type ID. So I am assigning an offer to a member, so I need to know what kind of offer I'm needing to assign and who should I assign it to. So those are those two things. And then finally, we get to the actual meat of the request. So the first two lines here, those are just entity framework junk. I need to load up the actual member object and load up the offer type object. That's going to be like, again, like 99% of the actions in my system. I first have to like load the data up to be able to work with it. And so that's going to be pretty much the same everywhere. And now I see the actual meat of the method. And the first kind of clue that maybe this method is a little too long are code comments. Code comments are a good clue of like, okay, if this method got too long, someone had foresight enough to like try to break it up into individual parts of the method and try to document, okay, here are the different steps that are happening. So step one, it looks like it's to calculate offer value. And as part of calculating the offer value, oh, here we go. Here's where it's actually calling out to some made-up web service to pass in the member's email and the offer type, and it'll give me back the actual value of the offer. Maybe there's some third-party system that keeps track, has like data aggregation, machine learning, blah blah blah. I don't know what's going on behind the scenes, but I do know. Give it the email, give it the type, and it will give me the offer value. So at the very end, the end result is I get a value for the offer. Next up is calculating the expiration date. All right, so this looks like based on the expiration type. There's two different kinds. There's an assignment type and a fixed type. It looks like assignment type is based on when I assign the offer to you, you have X number of days to use it, and then it's no longer valid. Like maybe it's your birthday and you have 20 days from your birthday, I don't know, to be able to use it. And so that one goes up based on when you sign it. And then there was a fixed expiration type. So that is, it's good for the month of May, so it's done May 30th. And finally, we have like the actual interesting part, which is assigning an offer to a member. So we have a first where it's instantiating the offer object. Then we assign the offer to the, well, no, actually, we add the offer to the assigned offers collection on the member. And then this is kind of a weird thing where we're keeping track of the number of active offers. And it's probably because we display that in a lot of places, or we use it for calculations or something like that. And so we want to pre-calculate that so it makes it much easier for us to be able to display it or use that information instead of having to actually join all the time to be able to get that information. And finally, the boring EF core stuff where I have to add the offer to the DB set thing, I guess, and then save the changes using the DB context. So looking at this, when I see this like this kind of long method that has a bunch of stuff going on, my first kind of instinct is to try to break up this method into individual smaller components so I can better reason about it. Now, this isn't necessarily something I keep all the time. Like I don't necessarily like put it in and keep it forever, but just to kind of help me reason about what are these different steps that are going on here and how do they relate to each other. So let's do that first. I want to break apart each of these like major sections of the method and just extract these into individual methods. So I'm going to be using, by the way, I'm using Resharper. It's not an advertisement for Resharper. There are certain things in here that are only achievable via Resharper and paid tools. I'll highlight those when I get to them. But I don't get paid by them whatsoever. It's just, I can't refactor without Resharper these days, so here we are. All right, so we have member and offer type and cancellation token, of course. We need to name our method, so I'm going to call, let's see. Oh, that's a good clue, hint. The code comment said calculate offer value, so maybe we just call our method that. Calculate offer value. Okay, that was reasonable enough. Let's do the same for the second method, the second section here. To extract this into, let's see, that code comment was calculate expiration date. Let's do the same thing. Expiration date. All right, and finally, the assign offer part. Assign offer. So all this helps me do is just be a little bit more, to have a little bit more understanding about what are the different steps in each of these different parts of the method. And also to understand what do each of those different steps use as part of their logic. So each of these methods has parameters being input into them. So that's like, here are the things I need to run. When I look at the individual methods, I'll also notice, like, is it using any of the dependencies being passed in the constructor? And then how do the different steps relate to each other? So does one value feed into the next one? And we can see that here, that the first value feeds into the third method. The second value also feeds into the third method, and the third method then does all the work. So this pattern right here is known as the transaction script pattern. The idea is that I have individual methods that represent, or classes that represent the overall actions in my application. And each of those actions has a transaction around it. And then the inside part is in all the business logic. Now, for a lot of applications and systems that I deal with, this is good enough. Like, it's okay not to make it any better than this if the code smells inside of the application or inside of the method don't lead us down those different directions. So in my systems, I always still start with this exact pattern. Just make it as dumb and as simple as possible. But when things start to get more complex and I start to see more behavior as part of that, that's when I start to use these refactoring techniques. So if I just stopped here, this would be a very short talk, so let's keep going. So what I'm going to do is take each of these methods one by one, look at the logic inside of it, and we're going to decide where should that logic belong. Does it belong here in this class? Does it belong in a different class? Does it belong in the domain model? Let's take a look. All right, the first one is calculate offer value. Okay, so as the parameters, I see member, offer type, and cancellation token, of course, because it's an async method. The other thing I notice is that this method is not static, which means it's using some instance field dependency of this class. And so I would see that because I've got this handy little underscore to help indicate which are the ones that are private fields here. So that's the HTTP client dependency. So looking at this method, I want to figure out where should this logic belong. And the way I can decide that is looking at what is this method most related to? One of these things being passed in, or something else entirely. So I look at member, and I say, okay, how is this method using member? Well, it's only using to get the email. So like just to get a piece of data out of it and then call some other web service, member is probably not a good choice for me to move this method to. Also, it's using a web service, like web services and domain models don't really mix very well, so that's probably not a good place to go. Offer type is going to have the same sort of issue. It's just grabbing one piece of data out of there, so that's probably not a good candidate for me to move this method to. So that's probably not a good thing. So, okay, if it doesn't belong in the member object, doesn't belong in the offer type object, could I leave it here? I could, but that would make unit testing this method more challenging because mocking out like this individual HTTP client is a bit more challenging than, say, trying to encapsulate this entire method in some single thing. So let's do that. Let's encapsulate and extract this method into some other object that would make our lives a bit easier to test. So I'm going to extract a class from this individual method. And it's got some, let's see, we want to first name this. And the name of the method was calculate offer value. If we're going to turn that around and name it, give that a noun, we would call it the offer value calculator. So let's call it that, offer value calculator. It's got some red here saying like, let's see, how to extract that. So the original class had this HTTP client field. I don't want this new class to reach back over and grab that HTTP client. I want to be passing it through to the class itself, so I'll do that. And the other next thing is this method is private, and so we'd want to make that public because of course we do. All right, so that method just disappeared. And then if I scroll to the top, now we have our offer value calculator with our private read-only HTTP client field being passed, or parameter being passed in, assigned there. And then the method itself looks exactly the same with the slight difference that this method is now public. Now coming down to my assign offer handler, it still takes an HTTP client, and then here it will new up the offer value calculator. So what I've just done now is I've created a class from this one method, and this right now is going to be a domain service. So a domain service is one of those classes that deals with domain objects. It's coordinating between them, but it's not like necessarily mutating them directly, or it's not mainly dealing with that. So that's what I've just created here as one of those domain services. Now this hasn't helped me in my unit testing yet. So in order to make it easy for us to use and test, we want to extract an interface from this class. So let's do that now. I'm going to extract oh no, not superclass. Extract an interface. I offer value calculator. Sounds good to me. All right, so now we have the interface, I offer value calculator, and this class implements it. I'm going to change the name of this, though. I hate class names that implement an interface that just have the same name minus the I. It doesn't tell me any clue about how this implementation of this interface is different than anything else, or what the kind of special thing it's doing. So this one I'm going to be calling the web service offer value calculator. If I actually, no, let's not rename that. If that was tied to an actual specific third-party web service, I would put it as part of that. Like, I don't know, there's Salesforce offer value calculator, whatever. I would put that in the name to tell me, this is the strategy in which this class implements this interface. Okay, so we've got this interface. So the next thing I'm going to do is this class in the original transaction script doodad is still using the derived implementation. So I want to fix that. I want to say, right here, by highlighting the type, there's this refactoring and Resharper that says use base type where possible. So it will look to see the usages of this field and say, wait a minute, can we use a lower type if possible? And what this will tell me, though, is I guess the old way I would do this, I would just change the type of that to the I offer value calculator and see what breaks. This is a little bit more intelligent about that. Probably not system.object, that would be silly. We'll use the I offer value calculator, leave the other options alone. All right, so I was able to do that safely. Now the last thing we want to do is it's not passing it in as a parameter, so let's fix that. So I'm going to say introduce parameter, and we'll still call it the I offer, offer value calculator. And also tells me that there are parameters that can safely be removed. Again, because I don't have any tests around this, so there's no actual usages of this constructor, so we'll fix that here in a second. Click next. Value, yes, it's warning me. I need to fix that. I will. And the last thing I need to do is make that the interface type, and I'm good to go. Almost. There is a way we can fix this. So I'm using dependency injection, so I'll go real quick over here into startup and say services.add HTTP client of the I offer value calculator to the web service offer value calculator. And then I would have to fill in like the actual, host information there, but I'll leave that blank for just to be easy on ourselves. Okay, so we took that one method that was dealing with some external web service, we extracted it into a class, thereby making a domain service, and then created an interface around that one method so that in order to unit test this, I could then mock out that one single method. If I had unit tests, but I don't. That would make this talk go way too long. So just pretend like I do. All right. So that fixed this one method. Now I've got these other two. So let's go into the first one, calculate expiration date. Okay, so looking at this, I see that there's one parameter being passed in, offer type. I also see that it's static, which means there are no dependencies that this method uses. So everything that it needs to do is contained inside this method using that one single parameter. Now, the first thing I see is a little squiggly note here that says, use switch expression. So let's do that, because that probably, oh, that's much nicer, isn't it? Let's see, can I make this even better? Can I do this? Oh yeah, inline that. Can I do this? Oh, okay, so that whole thing could be converted into one single expression. Pretty nice. Now, looking at, where could this method live? Again, it could stay right here. There's no, I don't have to move this method somewhere else. I feel like that this logic really belongs to this class. However, I do notice that it's static, so it's not using any of the instance properties, and this method only deals with that offer type object. And in fact, it deals with it quite a lot. 1, 2, 3, 4. 4 places that it's using that object. And so this is a code smell. This is called inappropriate intimacy. I wish there were a better name for that, but it's a method like touching another one a whole lot. And so I see this when it's poking into this other object for all of its information to perform some logic. That's a clue that like maybe this logic better belongs over there. So let's put it over there. Now, I used to do this where I would like go through several steps to eventually get over there, but I'm going to go like the cheat mode and make this much faster. There's a refactoring and resharper called make method non-static. And this is a kind of like a supercharged, like perform multiple refactorings all at once. And so what this does is says, okay, you have a method that's static, right? So how do you make a method non-static? You convert it into an instance method. But where should that instance method belong? What it will do is look at each of the parameters and say, do you want to move it to this individual parameter as the destination for this non-static method? Now, if I make this method non-static on the instance parameter here, then it can also convert all those usages of calling into that object. It can make this now just like instance property references instead. So let's do this and see what happens. Make method non-static. I have to select one of the instance parameters here. There's only one, so that makes it easy. Oh, method disappeared. Where did it go? Over to offer type. So a few things it did. One, it made it public, because it had to, in order for us to call into it from somewhere else. And notice that all of the offer type dot went away. And instead of like calling out into the other object, asking it for all this data, instead it's calling just directly into itself, which means that all of this logic is now encapsulated inside of the thing that it most deals with, that it's most concerned with. So that's a fairly like safe refactoring and fairly straightforward. Like now I actually have a behavioral domain model because I've got a method on my domain object that deals with its own behavior. Like all the logic to calculate this expiration date is now on the thing that has all the information about how to calculate the expiration date. So I think that's pretty cool. All right, so let's go back over to assign offer handler. All right, this is kind of a little weird now. I'm getting to the point where by the way, that this original refactoring where I had method that I've extracted out, that was known as the compose method refactoring, where I kind of think as like a table of contents of a story, where instead of having like a big wall of text, like reading Charles Dickens or something, then instead you break those individual parts into like the major components that they're dealing with, and then the method names kind of have those like title chapters that give you the clue of like what this logic is all about. But we notice we're kind of moving away from that because now the methods are somewhere else. So what I often like to do here, when I'm looking at the assign offer method, is saying, well, now I'm not really following the compose method refactoring because these methods no longer all exist here. They're kind of scattered about. And instead, let's do a little bit of defactoring. Now, defactoring is just simply the reverse of a refactoring. So if I have a refactoring of extract method, the defactoring would be to inline the method. If I wanted to extract a parameter, the inverse would be to inline the parameter. And so each refactoring will have an inverse or a reverse, inverse, a logical undo to kind of get it back to where it was before, or just to just undo or not really undo, because I could maybe not have done it in the first place. But in any case, I feel like this is no longer like the same level of complexity for each of these methods. So let's inline this assign offer method so we can kind of take a step back to see all the things that are going on. So for that, I will say inline method, inline all usages, remove the inline method declaration. And I don't know why it always does this, but it does. We're going to get rid of that one. There's a reason why I did that, why there are two parameters. It's because the method originally had one inside of it, and so this is just still preserving that behavior, just in case there was some difference between those two. Okay. So looking at this, I can see like, well, there are a few things going on here. I've got, again, the calculating the offer value. That's separated out in its own method. I've got calculating the expiration date, and I've got then the assigning of the offer itself. So if I were to look at this and then say, well, what should we then extract into a method to eventually move somewhere else? You could say, let's do all three. Like maybe I can get all of these out into its own method and then put that into like refactor that somewhere else. Or I could say maybe just this stuff, because this is all dealing with like just in-memory stuff. I'm not reaching out to some other web service. That seems like the most appropriate choice for now, but we will actually try in a second to pull it all together to see what that looks like. So I'm going to pull all of these together, extract a method, assign offer, and what we'll just say is like calculating the expiration date is just another step in assigning offer to a member, so let's just like pull that in as part of it. And the parameters being passed in are the offer type. I'm going to move that up because I like it. The member, the offer type, and then the value of the offer. All right. Now, the reason why I'm doing this, where I'm extracting the method first, is again because I just want to understand what is the data that's being used, what are the objects being used by this block of code. And it's really hard for me just to look at a block of code and just kind of think that I understand all the things that are going on. But by extracting a method, it kind of sets it in stone that says, yes, this is actually what's being used. This is the inputs being passed in. These are the outputs being passed out. And these are any kind of dependencies being used. By having this intermediate step of extracting into a method, it makes it much easier for me to grok and understand what is the logic of this section of code here. OK, so we're going to have the same exercise we did before. We're going to look at each of these objects it's being used and ask ourselves, are any of these a good candidate for us to move this behavior to? Now, this one's a little bit different in that it also has an output value that is also part of the domain. So that is also a valid choice to look at for where should this behavior live. So I've got member. We can count 1, 2, 3 usages. OK. Offer type. 2 usages, and one of them is just part of an assignment to something else, so that's probably not a great one. And then finally, offer down here. So it instantiates it, then assigns it to the other thing, and then returns it. So member and offer both look like decent candidates because they have a similar number of usages. Like member had 3 usages, 1, 2, 3, and then offer has kind of 3, well, 2 usages really, and then it's returning it. So then I look at, well, what is the nature of this operation? Like who should own this operation of assigning an offer to a member? Should an offer be responsible for assigning itself to a member? I mean, that's kind of, I guess it could, but it's a little bit backwards in my head. Instead, I think of like, if I want to assign an offer to a member, I see a member there, and I'm going to hand them the offer and say, now you sir, now have the offer. And so that's how it kind of matches in my head. And so that's where we'll try to do it. So again, what we'll do is do a refactoring to say, make method non-static. It asks us which of the instance parameters we want to try to move it to. And again, we can actually try each of these. We could go offer type. What does that look like? It looks horrible. Undo. What we'll do instead is just pick the one that makes sense, member. Ooh, it went away. All right, so going over to our member object. Now we have all the logic to assign an offer to a member, all fully encapsulated inside of this one single method. We give it the offer type, we give it the value, and then it does all the logic in order to assign that offer to the member. And now our method looks pretty small now. We have just one thing that says calculate offer value, and another thing that is to assign the offer to the member. Now, I'm going to do a controversial step here. Some people like it, some people don't, but I just want to show it just in case some people like it. So right now, the public quote interface of this object says, you give me the offer type, and you give me a value, and then I will assign that offer type to that member. But it doesn't encapsulate the nature of how it calculates the offer value and how it should calculate the offer value for an individual member. Instead, I can give it anything, like in32.max value. Like, I can do whatever I want here. It's not enforcing any kind of constraints about how the offer value should be calculated. So there is a way around this. And what we'll do is I'm going to first inline this value here as a trick to make my next step easier. And I'm going to go to the assign offer method. I'm going to say, I want to inline that parameter value. And by inlining it, it will, instead of you passing in the value directly, it will take the places where it's actually calculating the value and use that as the way to pass it in instead. So, inline parameter. And it's telling me that two new parameters have to be created. I have to pass in now the offer value calculator, and I also have to pass in the cancellation token because async. And I also need to do this as async task, not tag structure, I don't know what that is, of offer. Okay, so what did this do? Probably something like half of y'all hate, which is now I'm passing a service into a domain object. This is known as a double dispatch pattern, in which I'm passing now in a service object to a domain object, and then that domain object will then call back out to the service object, passing in the exact parameters it needs to be able to interact with that domain service. So what this allows us to do is encapsulate the interaction of our domain model with these domain services. And instead of having like calling code doing whatever it wants with these domain services, this is all about like, I as a domain object really need to be in charge of how I'm performing this operation. And so you give me the thing that can call the thing, and then I will pass in all the correct values in order to calculate that value. And now, we await the assign offer method to get the offer object. And now we can say, like, this operation is now fully encapsulated. I just want to highlight this as like a possibility. I don't recommend it in most cases unless you really need to have control over like what you're calling there, or especially if you look at a set of logic, they're like, you're calling the domain service like somewhere in the middle here. And you got stuff above it and stuff below it. So it's really hard to like extract out that one piece from all the others. So if it's really difficult for you to like, either pass in all those values of parameters or there's a lot of interdependency, that's why I say, well, just pass in that domain service to your domain model itself and let it do the work rather than you trying to like Jenga the thing out of there to make it happen. Again, it's not something I do often, but it is something I keep in kind of my back pocket in cases where the logic is just too intertwined with domain services. Some people don't like this in their domain model. I don't care. like async is a thing that we do these days, so it doesn't bother me if I'm not depending directly on like the Salesforce offer value calculator. It's going through this interface. This is just a way of encapsulating the full and complete logic of what does it take to assign an offer to a member in one single method. Okay, so what's next? We've got everything encapsulated, but I wouldn't say that our domain model is a, quote, fully encapsulated domain model, because over here I can do like wonky things like member.number of active offers equals n32.min value. Probably not something we want to let happen, right? Like, that's an important value that needs to stay correct. It's one of those invariants in my domain model that always needs to be consistent. And by just letting anyone do anything with this, then I'm not able to ensure that that value is always correct. Now you could say, well, if we just are really diligent about pull requests and code reviews, then that should never be incorrect. And like I would say to a point, but again, like if I'm trying to describe for my fellow developers, like here's the capabilities offered by my domain model, and there's no guardrails about what you can or cannot do, then we have to rely on like tribal knowledge to understand what is possible in our domain. So instead of like having this tribal knowledge, I want to really codify that in our code itself and not have it just be like in our heads. So the first thing we'll do to fully encapsulate our domain model is try to decide what are those invariants in each of these different objects. What are the things in those objects that if I took one of those things away, they would no longer be that thing? Like, when does a zebra become a horse? When you remove its stripes. And so we try to find those things in the model that if we took it away, it could no longer represent that concept of our model to our business. So going back to our member object, I would go to the business and ask them, looking at each of these different data properties here, each of these different pieces of information, which one of these could I take away and it still be a, quote, member? Now I will play the act of the business owner. And so looking at this to say, okay, first name and last name, we do need to know who you are because we have to put your name in the email, like a little header there. So we do need to know your first and last name. We also need to know your email as well, because that's part of the, part of you signing up. As you give us your email, you get, added to this mailing list that if you cancel, it takes, 21 business days to get off of. And so you need these three pieces of data in order to be a, quote, valid member. Now the other two are a little bit more technical, like they don't understand like, oh, I have to have this assigned offers property, but we know like, well, you have to have those other two as well. So let's codify that as part of this to say, when I create a member, actually it's not do that, let's create a constructor. Create a constructor, and the things that you need as part of being a member are first name, last name, and email. And we'll do this thing where if the first name is null, then we'll throw an argument null exception. I guess if we're going to be in C#11, we can do this. Right? Grumble. But if you didn't understand that, oh God, it's coming. All right, so you have to have a first name, you have to have a last name, you have to have an email. And the last thing we'll do is get rid of these public setters, because we don't want anyone just go mucking around with all of these values. We'll do private set, private set, private set. Now, right now, you don't see usage of this. Like in a fully fledged application, you would see usages of these setters because there's probably a screen somewhere of changing your first name, last name. There's probably a separate section for changing your email. So we'd have to go fix those as well, but because it's only a couple use cases, that's all we get here. Similarly, like here, we'll get to this one later. All right, so we got first name, last name, and email. Okay, let's also then do the offer object. Let's go to offer. All right, so we have member assigned, offer type, expiration date, and value. So I asked the business, like, well, what of these is like necessary for you to be an offer? And they look at us and say, well, all four of those are absolutely required for us to have an offer. I can have an offer like not assigned to a member, it's just like floated in the ether. It needs to have a value. They can't like write in their own value later. They can't expire forever, so we need to have an expiration date. So all of these things are required. Check parameters for null, why not? And then the last thing is, let's go ahead and make these private setters because we don't want anyone coming around and mucking with our junk. All right, the last one is going to be offer type. Similar exercise. They would need all 4 of these things, so I'm just going to leave that alone because in the interest of time, you get the idea. All right, so to make sure everything works, let's go ahead and compile. Oh no! We have lots of things messed up now. Okay, so first thing we have is the property or index or date expiring cannot be used as no set. Okay. Oh, that's something else. We'll come back and fix this. Oh, yes, we needed to convert this to a constructor. So let's just do that real quick. So we have new offer that is, let's see, this, then offer type, then date expiring, and then value. Oh, no, not that one. Let's extract a value here, extract a variable, and then now this one's going to be value. Okay, so that wasn't too bad. Okay, let's compile again. Oops. So this one's this is a totally different transaction script we have going on here. So this is one where I actually did need to mutate the expiration date. So let's do the same exercise we did before. Look at this method, seeing what are the different steps involved, see what methods we want to extract, and then move those methods to the appropriate location. So we first see data access junk, like not going to get away from this. That's okay. I never really refactor that. It's fine, whatever. So it's going and getting out of members. It's going to go load up the member object. Next, it's going to find the individual offer out of the member assigned offers. Okay. It's going to set the expiration date for today. Oh, yeah, so this is the expire offer handler. So this is all about expiring an offer. No, expire the offer. I guess because like if it's a bad offer or something like that, they'll say, okay, it's expiring today and you can't use it anymore. And then finally, it goes around with the number of active offers. So let's extract this into a method to see what information it uses. And I'll call this the expire offer method. Okay, so it's still dealing with this red squiggle. We'll fix that here in a second. But it's also, let's see, it's got this request. Oh, I don't like that. I don't like it when it's like dealing with this request thing. Let's see if I can extract a parameter for the places it uses this one value. So we'll call it offer ID, and it tells me I can safely remove the request object. I'm doing this because if I'm going to move this method somewhere else, I don't want to necessarily deal with these like DTO things. So let's convert these to parameters to make our lives a little bit easier here. Okay, so now it just passes in the offer ID property there, and now this method is a little bit more like simple here, where it's just dealing with member and the offer ID. Okay, so looking at this, we have the member object. I see 2 usages. Well, I can't move this method to a GUID. That doesn't make any sense. And so I could also look at, well, what about the offer object? I would have to extract a method for just that one part, and then, but that would be kind of weird to have this like chain set of methods here. So doing refactoring here, I say make method non-static. I select the instance parameter, member, click next. Okay, that went away. Now it's still red here, and this is because this date expiring is still a private setter on that object. So what I can do here is refactor this one single line of code, and then I will move this. I don't need this question mark. Go away. Do this again, make method non-static, because it's just dealing with the offer object. So now, this member object says, okay, first I need to load up the offer I'm interested in expiring. I will tell the offer, expire. And then finally, I will decrement my own number of active offers. So it's this aggregate is then like interacting with its own child entities in order to perform this overall operation of first finding the offer I'm interested in, and then doing all the logic necessary to expire that offer, which includes interacting with that other thing as well as interacting with my own stuff as well. Do we ever make this? Oh, this should have been private too. That would have also made our red squiggly before. All right, so at this point, offer now has a fully encapsulated model, like everything's private, and the only way I allow it to mutate are through the public methods or public constructors as part of it. Yes, there's like this compiler gets confused with the private sets. I'm using Entity Framework, so I still need these private setters. That's just a small concession. In persistence ignorance, it's fine with me, I don't care. And the last thing is, in my member object, all those operations are now 100% fully encapsulated, with the exception of this thing. So this is the last thing we're going to fix, is this public list, because we don't want people to do this. Member.offers.clear, like that would freak our business owner out. Like, what do you mean you can just like wipe a person's records of all their different offers? Like, that shouldn't be ever possible. So the last thing we want to do is encapsulate all the usages of someone just going ahead and setting everything here, and instead making all those operations against that collection completely encapsulated inside this model. So in order to do that, we need to convert this from this like auto property thing to have an actual backing field. So let's do that. And somewhere I need to do the magic refactoring. Maybe I do this. Nope. If I can't get in the next 2 minutes, that's fine. Here we go. We'll just do it manually. There's like a magic place I put my carrots in order to create a static, or create a, convert this auto property to, oh, there it is. God, I got it finally. To property with backing field. Ah, finally. Okay. So now I have a property with a backing field. I want to remove this setter because I don't want anyone to be able to do this. So I'll have a, we won't allow anyone to set this to expression bodied property. And this will now become whatever we want. Like IEnumerable is okay. We can do I read only collection. Maybe that's better for folks. And then this is now a private read-only list of offer that I only allow this one class to be able to mutate the assigned offers. And so down here where we're going to that property, instead, I go to that instead. And now I can say, yes, indeed, this domain model is now 100% fully encapsulated. How many of you like hated this part? This part right there? I figured so. So you don't have to do that. It's just throwing out there as a possibility. It's okay. All right. So we took an application that was using just plain transaction script patterns, where it was just database access, a bunch of business logic. And by using the techniques of these two books, we found code smells and used these refactoring techniques to slowly push our business logic down into our domain model, whether it was in the domain services or in the actual domain model itself. And then once we were able to push that behavior down and found that all the usage of the domain logic was in the domain, that then led us to be able to incorporate this fully encapsulated domain model where everything was private and only the operations that are possible through the domain are exposed on the domain. So thank you all very much. If you want to see the code behind here, the before and after, you can go on my GitHub, github.com/jbogard/presentations. Otherwise, have a great rest of the conference, and thanks for coming.